Hello and welcome everyone. Today we are going to explore one of the most fascinating mathematical patterns found throughout nature, the Fibonacci sequence and the golden ratio. Nature has its own language, and that language is mathematics. From the thinnest flower petals to the largest spiral galaxies, the Fibonacci patterns appears everywhere. Let's discover together how mathematics and nature are beautifully connected. The Fibonacci sequence is deceptively simple. It starts with 0 and 1, and then each subsequent number is the sum of 2 before it. So we get 0, 1, 1, 2, 3, 5, 8, 13, 25, 21, and so on. Now here are some fascinating facts about this sequence. It was discovered by Leonardo of Pisa, better known as Fibonacci, back in 1202. He first used it to model how rapid paraboloids grows. But what made this sequence truly remarkable is that it appears everywhere. In geometry, in art, in architecture, and most amazingly through the natural world. The sequence intimately related to what we call the golden ratio, which we will explore in next episode. The golden ratio, denoted by Greek letter phi, is often called divine proportion. Its value is approximately 1.618, and it's derived directly from the Fibonacci sequence. Mathematically, Phi's solution to the equation where is a line in divided such that the ratio of the whole to the longer part equals to the ratio of the longer part to the shorter parts. Here is some fascinating property of phi. First, phi squared equal to phi plus 1. Second, 1 divided by phi equals to phi minus 1. And most importantly, as the Fibonacci sequence approaches infinity, the ratio of consequent Fibonacci numbers approaches to this golden ratio. Phi appears in regular pentagons and pentagrams. The only number equal to it is reciprocal plus 1. Euclid, 300 BC, first described the extreme mean ratio. Phidias used in Parthenon sculpture. Leonardo da Vinci used in Vitruvian Man and Mona Lisa. Kepler called it the divine proportion. The golden ratio property, removing the square a smaller golden ratio creates a golden sphere found in Greek architecture, painting, and nature. To construction, start with the square, extend the side by phi to create the golden rectangle. Fibonacci. In plants and flower petal and Fibonacci number. We can see the different type of flower. The petal count is 3. We know that the Fibonacci number F4 equals to 3. Buttercups, the petal count is 5, and the F5 equals to 5. Kikori, plants petal count is 21. F8 equals to 21. And daisy, the petal count is 34 and 55. The Fibonacci number F9 and F10 equal to 34 and 55. And sunflowers, the petal count is 34, 55, 89. And Fibonacci numbers are F9, F10, and F11. You can here see the number of arc inside the sunflower. Also, we can see the sunflower seed as well. We start from 1, and the number of the astral is 34. Is the F9, the 9 sentences of the Fibonacci sequences. To set up astral, 55 and 34 or 89 in the sunflower is appear. They are the consecutive Fibonacci numbers. Also, it appears in pinecone or pineapple. In the pinecone, we can count here 1, 2, 3, 4, 2, 8. The pinecone 8 and 3 spiral we can find in the larger one, the 13 spirals, and the others is 8 spiral. Or pineapple 8, 13, and 21 spiral can be found. Or in Matulutio, the perfect golden ratio. Here we can see that the square here, each chamber is 5 times larger. Create a logarithmic spiral, maximize structural strength. Or here, the Fibonacci appear in animal. Example in hot scroll lighting patterns, chameleons, tails trolling Fibonacci S-drop, or butterfly wing patterns show Fibonacci properties. Here we can see the Fibonacci properties in butterflies. Or even in galaxies. The galaxies Fibonacci and golden ratio is appear. Many spiral galaxies follow the golden ratio. Distribution of S-star follows Fibonacci patterns. Here also we can see the golden ratio between the squares. And also in hurricanes, natural disaster follow the Fibonacci. Angular momentum create a drop. Here is a hurricane, and also we can see that the spiral pattern can be added here. Most efficient energy transfer follow golden ratio. And also in leaves, we can see here for cherry tree and for pear tree, the distribution of the leaves is based on the spiral and golden ratio. They are located based on the golden angle. Approximate is 137.5 degree. Maximum sunlight exposure. Minimize shadowing between leaves. They located based on this curve, based on this S-graph and golden ratio to minimize the shadowing between leaves. Or even in human body, all body follow the golden ratio. Here you can see that the ratio of this part to this one is the golden ratio, and ratio of whole part to this one is golden ratio. Hands bond each flanks is 5 times larger, or if face ideal proportion follow golden ratio. On here, S-graph follows Fibonacci. And the summary of the presentation, Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13, and 25, and so on. The golden ratio is the ratio of the Fn plus 1 over Fn that equals to 1 plus the square root of 5 other 2, approximately equal to 1.618. In nature patterns, follower, pin cones, sunflowers, and everything. Animal, it's also appear in animals, shells, horn, ring patterns. In scales, the galaxies and hurricanes also, the golden ratio Fibonacci sequence appear in human body bones, face, DNA, also appear. And inside the Fibonacci pattern are nature's most efficient way to pack, grow, and organize. Thanks for watching. See you in next video.